Okay, so we're going to finish up section 5.2 notes, and we're talking about frequency histograms and frequency polygons, which are the two main ways to type frequency graphs. And you'll see that each bar in the histogram, I'm not going to draw on it so it doesn't move again, that represents an interval. So in this case, it was 0 to 10, 10 to 20, 20 to 30. In the frequency table we made, it was marks in groups of 5. And then over here, what you see when you see all these numbers, the 10, 20, 30, those are the midpoints of the intervals. Okay, and I can't make the graph stop moving, so we're just going to have to deal with it. So anyway, the 10, 20, 30 there, that's what that means, the midpoints. So a histogram is like what you would think is a bar graph, okay, and it just has its own special name in statistics. And the reason why we don't count it as a bar graph is because technically it's not using bars, it's using rectangles, and the rectangles show the frequency of each interval. And then a polygon plots the frequency, so it puts down each point, okay, and then it connects the dots essentially. And you can draw, or we will learn to draw, frequency graphs. And the steps are on a piece of graph paper, so either you have some at home or you can get some in the class next time you're here. You draw and label a y-axis, so there's my y, and there's my x. Okay, and we usually draw arrows up and over to show that they keep going. And so on the y-axis we plot our frequency, and down here we plot our intervals. And then we use our frequency table, which we made for the marks, and using our frequency table we graph our frequency graph. And we create either a histogram or a polygon. So if you create a bar like this, or a rectangle, then you're making a histogram. But if you plot the points, then you're making a polygon. And of course you never would have both on one graph. I'm just showing that that's how you can do that. Okay, so if I tell you that we're going to draw something that has a frequency from 2 to 5, okay, so the numbers are going to be from 2 to 5. And so on our graph here, our frequency, okay, and this is the class data that we did with the marks, so the marks between 25 and 50. Okay, so we'll go back and draw from that. Okay, so remember that we had 5 intervals. Okay, so when we do frequency, down here we'll start at 0, and we can go, I'm going to make each plot 2, just so it's bigger. Okay, so there's my frequency. It's up to 5. And then my intervals down at the bottom, and I'm going to split this graph into 2 so I can show you. We'll do a histogram and a polygon. Okay, just so you can see what they would both look like. And again, normally you would not graph this on the same graph. I just want to show you both ways that you can do it. So down at the bottom, we'd show, so here for the bars, we can do, so 25 to 30, we can do each 31 to 35, 36 to 40, 41 to 45, and 46 to 50. And you can draw, so you do each interval. It's, again, you can write a little bit neater on yours. It's more difficult for me. So in my 20, I had 4. In my 31 to 35, I had 2. In my 36 to 40, I had 4. And in my 41, I had 5 in both of them. Okay. Again, please make yours look neater. It's difficult for me to draw. And these ones go here, so they match up. Again, these should match up a little bit better. It's just difficult for me to draw precisely on the board. And then for a polygon, remember that we have to use the midpoint of the intervals. Okay, so in my first interval is 25 to 30. I have to find the midpoint, which is 27.5. Right, since they're all intervals of 5, it would go up by 2.5. And you can find your midpoint by going up by 5 and dividing by 2. So for each interval start, we add 2.5. So here we'll start it here. We have 27.5, 32.5, 37.5, 42.5, and 47.5. And you'll notice that they all go up by 5 too. So there's 5 between 27.5 and 32.5, and there's 5 between each of those, which is good because our interval is 5. So in this interval we had 4, so I put a dot there. In this one we had 2. In the next two we had 4, or sorry, the next one we had 4, and then the last two we had 5. And so you would draw your polygon like that by connecting the dots in order. Okay, so some things to notice. That we can show the intervals along the horizontal x-axis or the midpoint for each interval. So we can choose either histogram or polygon. We only show the data as groups. Okay, so you can't see that, oh, some student got 27 out of 50 and another one got 50 out of 50. All you can see is that a certain amount of students fell in a certain interval. And so because of this, we cannot determine minimum, maximum, or median, okay? Because we don't know in the 25 to 30 range, you could have just had only 30s. We can't say, oh, well, somebody had to have 25. Same within the 46 to 50 to find the maximum. You don't know what the maximum is in there. It could be 46, 47, 48, 49, or 50. So the frequency table is a nice overview, but we can't tell the individual results. And then frequency polygons probably look pretty familiar to you, especially in a scenario like this one, because we can often graph them over top of each other. And so they use these a lot to show you know, the differences in time, or in this one it's the frequency polygon of birth weights. And so you have in the US, you have white women are the little black dot, black women are the open square, and then the triangle are African women, so women in Africa. And so you can see the difference in the birth weights. So looking at this, I can see that on average, black women in the US have smaller babies than both white women in the US and African women. And so using this, they can draw all sorts of conclusions, whether or not they're accurate. But these kinds of graphs you see a lot in newspapers and magazines and all that kind of stuff. Okay, so if you'd like to do some practice in your worksheet package that you were given in class, in worksheet 5.2, you can do questions 1 to 4. Okay, part 2, frequency polygons for more than one set of data. So here you show the data was collected for annual incomes of males and females in Canada in 2001. Okay, so you have the distribution of intervals. Okay, and let's count, or sorry, the distribution of earnings, and we can count our intervals. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 intervals. Okay, and we can find our midpoint too, just in case we want to graph this as a polygon. So under 5,000 would be 0 to 5,000, right? And the rest show you what the distribution is. So our midpoint here, midway between 0 and 5,000 is 2,500. Midway between 5,000 and 10,000 is 7,500. And we can go down and fill those in. If you're not sure how we got those, add them up and divide by 2 and make sure that you get the same that we're getting. 22,500, 27,500, 32,500. Again, you'll notice that between each of the midpoints, there's 5,000 difference. 37,500, 42,500, 47,500, 55, 500, or 55, yeah, 500. Just one second. Sorry, this one here you'll notice this is different because it's a 10,000, so this midpoint is 55,000. And 60,000 over, we can't really count this one. We just kind of have to put the plus. So these two are different than the rest. Okay. And then we look at, well, how is the frequency given? The frequency is given, so F is given as a percent. Okay, and the range is, let's find the lowest percent, 3.3. So ranges from 3.3 to the highest percent is 18.4. Oh, that's a lot of males who are making the highest. So then when we talk about what our vertical axis, our frequency axis will look like, so I start from 3.3 to 18.4. So I'm going to number my vertical axis. So y-axis, I'm going to go between 0 and 20%. Okay, you don't want to start at 3 and go to 18.5. Give it a little bit of wiggle room so your graph looks nice and neat. Okay, so then we can graph this using polygons. So remember that I'm going to plot frequency over here, and we talked about how frequency was given in percent. And then since I'm going to do polygons, I'm going to do the midpoints over here. So I'll start 0, and then down here I'll have, okay, just one second. Okay, so I'm going to fill out my polyglot. I'm going to get you guys, or polygon, I'm going to get you to fill out your polygon. So just pause it, fill out all the data. So again, you're along the X or your Y-axis and along the X-axis, and then we'll come back and we'll compare them, okay? Okay, so oh, it was impossible for me to draw on this graph, so I just pulled up my key. So you can see that I made the males a solid line and the females a dotted line. You can also do different shapes or different colors or highlight or however you want. On here it's easier for me just to a solid line and a dotted line. And so you can see that the men make much lower than the women in the lower, or there's less men in each of the lower categories, but significantly more men than women in the higher categories. And if your polygon does not look like this, go back to the data and try drawing it again. And then if we go back here and we're asked to describe any differences between the two sexes, so there's a higher percentage of females compared to males. Just erase that. Compared to males earning under 2,500, because that's the midpoint we used, and a higher percent of males earn over 60,000. Okay, so basically, again, if we look at it, the female curve is above the male curve, and here it goes here, like here, until you get to earnings right here. Okay, and if you look at who commissioned this study, it tells you, so this is income in Canada, and it's being categorized under women's income and poverty in Canada. Okay, and then the last part of the notes is going to be interpreting frequency histograms and polygons. So if we look at this histogram here, and this is the number of patients seen in a clinic according to their ages. So the histogram is showing ages. So when we say number, this is really our frequency. Okay, and we look for the highest and lowest number. And we always are assuming that elderly people are, you know, taking up the most of our healthcare, and they're going to see the doctor most, and they're clogging up the system and all that kind of good stuff. But if we look at the highest one here, the highest is actually in the 40 to 50 range. And the lowest, if we scroll back down to this, is way over here in the 80 to 90 range. And granted, of course, and this is what I mean, that we're always having to interpret the data we see. Depending on which year this was taken, we have to think about why this would be 40 to 50. Well, if this were taken especially 10 years ago, the baby boomers, a huge percentage of them were at age 40 to 50. And of course, 80 to 90, there are less people alive in the age of 80 to 90, and less people who would be going to see a doctor in a clinic as opposed to already in the hospital or in a care home where there's a doctor there. So what is the age group that is most frequently seen at the clinic? It's 40 to 50 years. Is it true to say that patients who are 85 years are seen, so 85 years old exactly, are seen least frequently? So is that true? Can we say someone who's 85 years old will be seen least frequently? If we look at the histogram, we cannot say that. So we can say, or it is true to say, that patients 80 to 90, not 85 years old, are seen less or least frequently. But we can't say 85. We can't say that that's the midpoint. And why can't we say this? Because we cannot see the individual ages. All we can see are the intervals here. So we can see intervals of 10 years. So you can now do questions 5 to 8 in worksheet 5.2. We'll have a small quiz on section 5.1 on Tuesday, and we'll continue on the notes then. Okay, have a great weekend.